Okay, hi everyone. My name is Christian Melendez. I'm gonna talk about the 7 container design patterns that you will need to know. Actually, there are other design patterns that you will use for distributed design systems, but I choose to talk about just these 7 for this time. So let's start with why containers. Well, containers are there's no doubt that they're used by many companies right now, many organizations right now, and the trend is growing. You can see from the graph here from a study from Datadog. Datadog is they collect this information with their customers, so they know they have a pretty good information about how the trend is going with the adoption of containers. As you can see, since Docker specifically started working in 2014 to January this year, you can see a big increase here. So there's no doubt that containers are being adopted now more and more in these days. So the reason for that is because they offer isolation, they offer portability, and they are also a good vehicle for your DevOps implementation. So why don't we keep talking about the topic for today? The reason that I choose this topic is because in 2016, the co-founders of Kubernetes, Brendan Burns and David Oppenheimer, published a paper called "Design Patterns for Container-Based Distributed Systems." Basically, in this paper, they talk about the container, the design patterns that I'm gonna talk about these days, and basically they use the analogy of using these patterns that have worked for software development, that you can also implement those in distributed systems, and specifically for containers. So, as with software development, as I was saying before, most of our problems are not unique. The problems that we are trying to solve, that we work on our daily basis with our applications, are not very are not unique. Let's be honest. We all have the same problems in the industry. We are all trying to work at scale with our applications. We are specifically, if we are deploying our services through an API. Let's be honest. Our problems are not unique. Someone already had this problem before. So the difference is that what are the outputs? What are we doing with all of the pieces that we have at our space, that we can create something different that is going to be unique. Actually, the outputs are going to be unique, but not the problems. So why would you use a container design pattern in this matter? Because we will have a shared vocabulary, the basis for other concepts. We could be using this design patterns to explain other architectures, to explain other patterns. And because you already will know about, for example, one of the patterns that we're gonna talk about is the Sidecar pattern. When you read or hear someone talking about that pattern, you will be able to understand more quickly the other concepts that that person is trying to explain. So again, as with software development, those patterns are gonna be a shared vocabulary that we all will understand and get better information when we're trying to go deeper into some other solutions. Also, the other benefit that you will have when you use design patterns to create your applications, specifically in containers, is that you will have a shared library or shared components that you could be reusing for other parts of the system in your company internally, or you can start sharing that with the community, as you've seen with other companies are doing. And the idea is that you could have a solution for common problems by using design patterns specifically to containers, because we already know that with containers you could create an image, you could publish that image in the Docker Hub, for example, or you can publish the Docker file in a GitHub repository, and everyone is having the same problems, because remember, the problems are not unique, will be able to use that image and solve the problem, the same problem that they're facing. So it is better to have these patterns, not just because of a shared vocabulary, but also because you will be able to share common solutions for problems. So in a nutshell, design patterns for containers are gonna be useful to have a shared language to known problems. That's basically the idea. We're gonna start talking right away for those patterns. Let's start with some of. I'm gonna start with 4 patterns that are basically specific for a single node. That remember that we're gonna start simple, but as I continue talking about these patterns, I'm gonna keep going back with the same concepts with the concepts that I talked before, because the idea is that you can again reuse these containers in other parts of the system, in another solution proposals that you have. So let's start with the single container, and this is a simple one, because it is again the benefits that you will have by containerizing your application. You will have, as with containers, you will have established a reserve boundaries for the application, meaning that you will reserve certain amount of memory, certain amount of CPU, or things like that, because the idea, it is a good practice that you have that reservation, because that will be the foundation for how to scale in your application. So it is always good to have that boundary. You also will gain another benefit about isolation, because the idea again is to make a better use of the infrastructure that you have, and you could collocate same different applications in the same host. And with containers, you could be sure that you won't affect other applications when a certain application is behaving nice, doing nasty things or things like that. Other application won't get affected. Also, what I want to stress this time is that you will have a separation of concerns, meaning that you will have one responsibility for the container that you are creating. From now and the other patterns that I'm gonna explain, this is basically the idea. You will have only one responsibility for that container. Even though we're gonna mix this, we're gonna mix things with other containers. One container, one image will have only one thing. Will have only one, for example, a backend application. Even though your application is composed of a front end and a backend application, it is not a good practice that you have that in the same image. Even though if that's possible, even though if you think that that will give you a better performance, as I will agree with you, let's try to have that separation of concerns in separate image. We will work on that later in the following pattern, how we can work on that. So this pattern is the most common one that maybe you have heard before, is the sidecar pattern, which consists of an application container and another container that will extend. I'm stressing this part because in this case, the sidecar pattern is about extending the behavior of the application. As you can see in the image here, you will have an application container and it will be sharing the disk network, etc., with the sidecar pattern. If we are talking about Kubernetes, that could be grouped in a pod that they will live together. But again, the idea is that you are not having different things in the same container. Why? Because, for example, let's say that if something happens in the sidecar pattern, just because something happens there doesn't necessarily mean that the application container will start crashing or failing. Because, for example, with some of the examples that I'm gonna give you later in the following slide, you will see that it doesn't matter for some cases. It shouldn't matter if the sidecar pattern fails. The application container should continue be working. So, what are the characteristics of the sidecar pattern? Is that you will be scheduling the same containers. You will be co-scheduling the containers in the same node. And even to a more detail, to a more granular level, you will be scheduling them in the same pod. For example, if we're talking about Kubernetes, the idea is that you will have a better performance when you are communicating between those containers. You will be sharing resources like volumes and things like that. And one of the examples that I have here for you is that you could be creating a sidecar pattern for a sidecar container for that will be managing the HTTPS offloading or the SSL offloading of the application. Let's say that, for example, your application is a legacy application and you don't want to change that too much because it will be hard for some reason to include the HTTPS layer. So one way that you could be working on that is to create another container that will be serving basically the HTTPS protocol. But again, in some scenarios, this won't be enough because, for example, in Europe, the GDPR stands that every communication between companies should be in a secure manner. In a secure manner. But again, this is one example of the sidecar pattern that you could be using. Another example is that you could be using a container application for a self-hosted application that is, for example, a service, Linux service, and you will include another proxy, an HTTP proxy for that application. I've used this pattern of application in the past in a company where we had a Linux service that it was not HTTP or web based natively, so we had to add an HTTP proxy, and the problem was that we had everything in the same machine, in the same host. When we start adding containers, we again put that in the same container. But the benefit that you will gain by when you separate this other proxy or this other application into a separate container is that you will be able to reuse this container for other problems. And another example that I didn't specify here is that you could be using the common problem or a common scenario for the sidecar pattern is that you will have your container application that will be reading the logs into a shared volume, into a file system, and the other application will be pulling those logs or those files that the application is reading, and it will process those files, and it will be sending those logs to another centralized logging repository, for example. So the next one is the ambassador pattern. The ambassador pattern basically consists of an application container again, but the difference here is that the ambassador container will serve as a broker between the application and its consumers. It will be grouped again as with the sidecar pattern in the same machine, in the same node, in the same pod, for example. But the ambassador container will be basically working as a broker to the external world, meaning that the application container will be agnostic to what the external services the application is interacting with. So they are modular. They are reducible containers. That again, most of the patterns, not most, but all of the patterns that I'm gonna talk about today is that you can reduce that. You can create something that is reducible for other parts of the system or again for the community. You could be having this like for example here in the image here, you could have the ambassador container working as a load balancer, and you will say to me, well, but I can solve that as a load balancer, and I can add a load balancer in the cloud or in my infrastructure, and that will be serving as a broker to the other parts of the application. that will be that could work. But the idea is that by doing that, there are always trade-offs, right? So you will be needing to add something else, whereas where if you have this in the same the part of the application, you will be able to reuse that part. So again, there's always trade-offs that you could be using. For example, in your development environment, you will be using instead of that ambassador container will, instead of interacting with an external service, it will interact with a local service in the same node, for example. But you could be using that, and for the application, it will be the same. It will be agnostic. Some of the examples that you will have in the ambassador pattern is that a shared you will have a service that has a sharding data, and the ambassador pattern will serve as a service discovery, for example, or you will have a service brokering that it will be used under the hood, IaaS application or a PaaS DB database for the application. You could, for example, use A/B testing scenarios that you could be using. You could put that behavior in the ambassador pattern, and that will split the traffic to another external services, as the picture that as the image that I was sharing before. That's basically the ambassador pattern. And again, guys, folks, I'm gonna be giving a big overview of the patterns because we don't have too much time. But I think that it is worth it to keep investigating this. So the next one is the adapter pattern that consists of, again, an application container, but in this case, it's similar to the previous ones, but in this case, the adapter container will modify the interface of the application. What does that mean? As I was saying before, with the example of the logs or the application that it was reading the log files, reading to local files the logs, and the other container was actually pulling those logs and pushing them to a centralized repository. In this case, the adapter pattern, you could be using a container that it will be in charge of standardizing the communication between your application and the other resources. Meaning that, for example, we all know that for metrics, all different applications use different metrics in a different formats, in different manners. They communicate, they save those logs in different ways. But the adapter pattern will adapt, as the word says, to that different protocol or different standard or different format of the metrics or the logs, and it will work on having that structure in a way that it is useful and it is more easy to read or to consume for analyze and give it another type of information to those logs. So basically, the adapter provide a consistent interface between the application and the external services. And again, is the purpose is to have reusable models that you will have. For example, you will be create an adapter container that will be reading logs from an Nginx application, and it will be transforming that, and it will be sending that to a centralized repository location. The idea is that you could have that container working with environment variables, for example, and depending on where you're using that container, you will be sending those logs to another part, to another place, for example. But the idea again is that you will have a reusable container. Some of the examples that you will have for adapter design patterns are collecting metrics, for parse and store logs, like log styles as fluentd. The logs or fluentd could be the adapter container pattern, or you could have custom health checks for the application. You could be using that adapter container to perform health checks to your application, but not just health checks like it is a live application, but more intelligent health checks like running SQL, database queries to the application and things like that. You could have more intelligent health checks application that again you can use for other parts of the system, for another microservice, for example. So the overview of the single node patterns is that you will have the single container. You will isolate where you will isolate. You will have portable containers, and etc. Basically, all the benefits that you will have by using containers. The other pattern that we just saw is the sidecar pattern, that it will work to extend the behavior of the application container. The ambassador pattern will work as a broker or proxy to exterior, and the adapter pattern or the adapter container will basically work as a consistent communication between the application and the external world. So those are the basics for the four basic patterns for containers. And again, I know that this sounds like, well, that's obvious. That sounds pretty obvious. Maybe this is not only for containers, but these actually patterns, these patterns actually are for distributed systems. But for distributed systems, using containers is more easy to work with, but because of all of the benefits that you and I know about containers. So let's go rapidly with multi-node patterns. Multi-node patterns are used for scale at the node level. You're not going to be using those containers in the same node, meaning that you will be using other computers, other servers, and you will scale your application into different nodes. You will have a loosely coupled application or architecture, and you will be able to communicate with between those other components or those other containers by using a network calls. You will be able to use to execute parallel calls natively, and these are basically the base for microservices and a stateless application. Again, so let's talk about the scatter gather pattern. The scatter gather pattern basically split a big task into smaller ones, and those smaller tasks are gonna be run simultaneously, and the principal or the main container will combine those results later. So as you can see here, the user will request to the main container, and that container will shard the calls to smaller tasks, and the main container will wait for that response and will give one combined answer to the customer or to the user that made that request. Again, you will have containers for the partial processing. You will work with having you could work with one container. You can scale those containers depending on the needs that you will have, and you will have the container for the main container, the main application that will receive the request and will combine then the results of all the partial calls that the container made. You will be able to have multiple threads for the request and for the process, and it is similar to the MapReduce programming model. I'm not sure if you're familiar with that, but this is basically the pattern that it is actually applies better. The example that applies better to this pattern. Usually, this pattern is used for distributed searches, like as you saw in the previous image for sharding purposes. You will have the trade-off or the downside is that the response time is the sum of all of the requests that the main container is doing. So one way to work with that is by setting timeouts or having replicas if the node fails, for example. So basically, that's the scatter gather pattern. Let's talk about the leader election pattern, which basically is as simple as with distributed system. You have three masters, like in Kubernetes when you work with the control plane. For the etcd nodes, for example, you will have one master that is selected. That master fails, then you will have the system or the architecture will basically select another master. And with Kubernetes, you will have, for example, if a container crashes, it is recreated. If a container hangs, it is gonna be restarted. And if the node fails, the container is gonna be rescheduled. But the application might need a high SLA, And even though this is gonna be really useful for your application, sometimes their SLAs are higher, and this is not enough. So that's why you will have a leader election pattern in place. So reduce, don't reinvent the wheel, because these patterns are actually usually hard to implement. Algorithms like Paxos or Raft are gonna be used for this pattern. You will have one of the examples that I'm not gonna deep dive on this, but I'm gonna just give you some example of where these applications are, where some applications are using this pattern. You will have the etcd, for example, Zookeeper and Consul. If you deploy those into Kubernetes, you're basically gonna be applying the leader election pattern. Last but not least, we have the work queue design pattern. That it is very simple. You will have the manager container that is going to be the one that is there. That you will have work items, and that will end up in a manager container, and that will make sure to make concurrent calls to the worker containers. And again, if you're using Kubernetes, you can scale that horizontally to another containers, for example. And that's cool. You will basically, the idea is that you will have a container for the manager queue, and container one image that you can scale horizontally for the workers. So that's basically, I know that I didn't talk too much about these patterns, but we don't have too much time for this. But I want to leave you with this: the why. Why would you use design patterns for your DevOps implementation? Basically, is to reduce the lead time by increasing the deployment throughput with scalable and resilient applications that you will have when you implement these containers in a distributed applications. So if you want to learn more, you can download the book where talks in much more detail about this topic, and you can have that for free. And what is cool about this book is that you will have hands-on exercises, and it is written by Brendan Barnes, the co-founder of Kubernetes, the same guy that published the paper that I was talking in the beginning. So thanks. That would be all for me. Thanks to all the sponsors, and especially the supporters. And I'm gonna give kudos here to the Guatemalan meetups that are gonna have viewing parties later today. So thank you, everyone, and meet me on Slack on the specific channel. And if you have any questions, I will be there for you. So thanks.